the homework? Yes, okay. Let's take a look at exercise 3B first. Any problems with question 8? Question 8. How about question 11? 12? 15? 15? Okay. 15, would I say that the problem is in the writing part? Or for question 15 is the writing part? Okay. I really want you to give the writing part a try. Okay, so try to phrase it in your own words as best as you can. Okay, then after I mark ready, then I address it. Okay, so I don't want to go through question 15 if the concern is in the writing part. Okay, I really want you to just give it a try. Alright, see what is it that you will have first. Okay. Then I will go through question 15. Okay, how about exercise 3C? Question 4, 7, 9. Any issues with 4, 7, 9? 9. What is the issue, Megan? The third part. For the box and whisker plot for cloud, why the left whisker is much longer than right? Explain what this means. So, what do the whiskers mean? So again, back to the concept. The whiskers means 25%, 25%. So lower 25% has a wider spread than upper 25%. Okay, so try that out in your words. Alright? Okay? So, writing really, okay, go back to your concepts and try to write it in your words. Alright? Because we are now already at 8:20. Okay. Homework, could you please submit to Mingsan, okay, by the end of today, right? Mingsan, help me collect and place it in my locker, okay? Because I really want to finish up our e-maths today, so that next Monday we can start very nicely on our e-maths. When we talk about standard deviation, okay, we said that standard deviation is a measure of spread and it is related, okay, to the mean itself. Okay, how much deviation there is from the mean. Okay, so you can see as though it's like a plus minus of value. So let's say if the mean mark of the class is, let's say, 60 plus, okay, maybe 60 marks itself, then the standard deviation is, let's say, 13. Okay, that means most of the people in the class, okay, deviate from these 60 marks, okay, this mean of 60 marks of a plus minus 13, okay, so can be plus 13, minus 13, or even within the 13 range, okay, can be 12, 11, and so on and so on, right? So last lesson we also, okay, learn how to use our calculator, right, to figure out how to find the values of standard deviation. So today we're going to look at how do we make use of this information to make comments, okay, or draw conclusions, right? So let's take a look at practice now 7. Okay, so the other time round, in pressing our calculator, we already found our answers for part I. Okay, sorry, let me just write the question up. Tell you what the question is too long. Let me just set up my laptop, okay? Sorry, in the meantime, can you just read the question? Okay, so this is the question, huh? Okay, in part I, right, we have already found out the standard deviation, okay, for the grammatical errors that this boy Yihao made. In part 2, we are given the information of the mean and standard deviation of the number of grammatical errors that another student, Bernard, actually made. Okay, so no need for us to calculate for Bernard, but for Yihao we have already calculated it. The part 2's question is to make 2 comments comparing the number of grammatical errors made by Yihao and Bernard. Okay, although in part I, they didn't ask you to find the mean value, we definitely need the mean value in order for us to draw the conclusion or make the comment. Because as always, whenever we need to make any comment, we compare in terms of the mean, that means in terms of average, and then we also compare in terms of the standard deviation, in other words, in terms of the spread itself. Okay, so in part I, if you use your calculator, okay, to look for the mean itself, you would probably be able to get about 13, in fact it's exactly 13, and the standard deviation, which we did the other time round, was 7.18 to 3 SF. Okay, now we compare the values to part 2. Looking at the mean itself, right? Okay, the mean for Bernard is 15, while the mean for Yihao is actually 13. That means that in general, Yihao made lesser grammatical errors as compared to Bernard himself. Okay, so that is the first thing that we can actually write down. So we say that Yihao so that's the first thing that we can comment and conclude based on the comparison from the mean. And then from the standard deviation, which is a measure of spread, we see that Bernard has a value that's 10.1, and then for Yihao, the value is actually 7.18. That means that, okay, for Yihao himself, okay, the spread itself is actually more consistent, okay, closer towards around the mean. So we say that lesson itself, I have asked you to actually try pressing this in your calculator already. I hope you did so. Okay, the value, the standard deviation should be 3.74. Okay, so I shall not go through this. Alright, so for practice now 8B, standard deviation that we should be getting is 3.74 when rounded to 3SM. Okay. Instead, I want us to take a look at practice now 8A now, which is at page 121. So looking at practice now 8A, let's read through the question. It says that Cheryl measured the lengths of 10 pencils. The mean length of these pencils was 18.8. The standard deviation of the length of pencils was 0.7. That means as she measured the mean size, the average size is 18.1, and then there's a deviation of 0.7, okay, for different pencil lengths. Then it says that the measuring device being used by Cheryl was found to be inaccurate. Okay, the correct length of each pencil was actually 0.3 cm shorter than what Cheryl has measured. So every single length, okay, it is supposed to be a deduction of 0.3. Okay, we want to write down the correct values of the mean and the standard deviation. Okay, so you need to realize how mean is actually being calculated in order for us to understand what should the mean actually be, because we do not know the exact lengths of all these pencils itself. Okay, so for the mean, okay, the actual mean itself, it should actually be 18.1. That means the inaccurate mean minus away 0.3. Okay, such that we get 17.8 cm. Alright, why is that so? Let me just illustrate with an example. Just trying to help you understand why is it that the correct mean is just taking the original mean minus 0.3. Imagine that there are two pencils instead. Okay, so for example, you measured the data value to be this star and this triangle. Okay, I don't care what is the number itself. And then we know that the mean value will be to take these two and together then divide by 2. So imagining two pencils. Okay, the correct mean should be to take the inaccurate value minus away 0.3, then plus again the inaccurate value minus away 0.3. We just do a little bit of algebraic manipulation, shift things around, okay, just by opening up the brackets, the operations to change. We find that, okay, eventually the number of 0.3, okay, is the same as the frequency number in the denominator. So eventually the 2's cancel out. We get a minus 0.3. So this star plus triangle over 2 is actually an inaccurate mean. Okay, so the inaccuracy itself, okay, does somehow get averaged out as well. So we just have to take the inaccurate value minus away the 0.3. Okay, why minus? Because the question said that the correct length is actually 0.3 cm shorter. Okay, if it were to be longer, then you should be adding 0.3. Alright? Okay, so the inaccuracy itself does average out. Okay? Then for the standard deviation, right? Okay, the standard deviation actually there is no change at all despite the inaccuracies. Okay, so the standard deviation will still remain at 0.7 cm. Okay, why is that so? Because the exact value itself, right, okay, while it changes, it reduces, okay, going down the line, okay, the deviation from that mean value actually doesn't deviate because everything shifts, right, all the data values end up shifting. Okay, so imagine it like it is a dot diagram. Okay, so just giving an example. Okay, imagine that you measure the pencils and all of them have values that is something like that. Just using 5 dots over here, imagine 5 pencils. All of them actually decrease in values, okay, minus 0.3. So each of them, by right, they should be lying over here in the dot diagram. But the spread itself doesn't change. Agree? Because standard deviation is the measure of spread. Okay? So while these data values have shifted to over here because of the inaccuracy in the measurement, the deviation itself, the spread, doesn't change at all. That's why for standard deviation, it still remains at 0.7 cm, okay, despite the inaccuracies. Okay? Questions? Looking at practice now 9, which was also a question I asked you to press your calculator for. Okay, why just do a quick check that we are able to press our calculator and get a standard deviation of 1.98. Okay, are we able to get that? 1.98 is to 3SF. Okay, so to interpret the data, over here, right, it says the number of heartbeats per minute, okay, of 40 adults is shown in the frequency table below. So the data value that you're measuring is actually the heartbeats per minute. So you should recognize this as your X value and this as your frequency. Okay, because we are counting the number of people that share this data value itself. Okay, so make sure that your table is actually arranged correctly. Any issues? Okay, I see some of you pressing and let you press first. Okay, before we go on to the next question. Right, shall we take a look at practice now 10A? Okay, then we go through our calculator again, alright? Okay. In practice now 10A, It says that there are 30 students, each from Class A and Class B. They were surveyed on their weekly savings. So the data that we're trying to collect is the weekly savings. Okay. Then the information is shown in the table below. In this table itself, notice that the savings are actually being grouped into intervals, so you do not know the exact data value. Okay. So long as you have savings that are between $0 to $4, with $4 inclusive. Okay, there are 3 people, okay, who actually have that amount of money of savings. And then subsequently, as you read the table, it also goes this way. So this would mean that there are 14 people that have savings between $8 to $12 per week. That is for Class A. For Class B, they have already calculated for you the mean and standard deviation, no data given at all. Okay. In Part A, we want to find the mean amount. Right, now how do we press our calculator with information given to us like this? Because our data value being x over here is given as an interval, we do not know the exact data value. Okay, back when we were in Sec 2, when we learned this idea of statistics, okay, we learned that when it comes to group data that is of intervals like that, I need to go and find this thing called mean value, okay, to estimate it. Right, so to find the mean value, I take the lower bound and the upper bound, add together, divide by 2. So 0 plus 4 divided by 2 will be a value of 2. I consistently do it the same way for all. Okay, 4 plus 8, 12 divided by 2, 6. And then you will be able to get this range of mean values. So the mean values are the one that you will press into your calculator. Okay, so press in your calculator the mean value, and then the frequency will be 3, 8, 14, 2 and 3 respectively. Alright, I want you to give it a try now. Check what is the mean amount that you're getting. Try now. I give you about 2 minutes to press into your calculator. Check that you have mean $9.20, standard deviation $4.18. Okay, will you do that now? Again. So we have mean, we have standard deviation, we draw our conclusion based on that. So in general, comparing the mean itself, with Class B being $9.70 and Class A being $9.20, what is it that we can conclude? What do you think? Matthew, what do you think? People in Class A save less, okay? Okay, but how would you write down as your answer? Will you just say people in class A save less? Full stop. Okay, I don't recommend that you lump everything together. Alright, so what Matthew was saying just now, okay, he put the comparison of mean and standard deviation, everything together in one statement. Right? Please keep them separate, two separate statements, okay, because it will be very confusing from the reader's point of view to understand what exactly are you comparing. Okay, so first observation is that the mean of class A is actually lesser, so they actually save lesser weekly. So that is based on the mean. We write that down first. Okay, so students from class A save lesser weekly than those in class B. So he said that the mean of the former is smaller than the mean of the latter. If you want to use this former and latter term. Okay. Then we talk about the standard deviation. Okay. By the way, in your calculator, okay, when you calculate your standard deviation, it will be a longer decimal. In this particular case, because you're talking about money, please don't be fixated in thinking that it must be 3SF all the time. In this particular context, you should be rounding to the nearest cent rather than 3SF. Okay. So do look at the context carefully, although $4.18 happens to be 3SF as well. Okay, so when it comes to money, rounding off should be to nearest 1 cent. Okay, in other words, 2 decimal places. Alright, so back to the comment of the spread itself. Okay, just now what Matthew was saying is that we're looking at consistency. We could do that. Okay, so the standard deviation for class B is $3.10, which is smaller than the standard deviation for class A, which is $4.18. Okay, so that means that the students in class B, they save more consistently to the median, to the mean, okay, as compared to those students that are in class A itself. Right, so that is something that we would say as well. So students Oh, then that's all. Sorry, I wanted to say that. Okay. Could I give you 2 minutes to give practice now 10B a try? Again, you have your group values over here. So we need to go and find the mid value. Alright, and then this will be your frequency. Okay, give this a try. Give you about 2 minutes. Standard deviation that you managed to get. That's why someone. Really, what is the standard deviation that you got? What do you get? Standard deviation. Really now become Nobel already. Yes, really. Standard deviation. Oh, is it? 12.1. Okay, do we all get 12.1? Alright, so no. Got somebody say no? Can get 12.1, right? Okay, so the mass itself, always find the mid value. In this case, your mid value should be 5, 15, 25, 35. Okay, just be very careful. Don't always assume there's a pattern going on for your mid values. So let me just write down first your mid values. Okay, some people like to assume and then start maybe writing 5, 10, 15, 20, 25. Okay, so do be very careful. In this case, it's actually a difference of 10. Alright, but it may not always be uniform as well. So always lower boundary, upper boundary, and together divide by 2. Okay, then you get the correct values. So going to the last 2 questions. Okay. Exercise 3D. Oh no, I don't have much time. Okay, question 8. I just want us to know how to find standard deviation if we are given a histogram. Okay? There are many different kinds of histogram. A histogram is not a bar graph. differentiate them. Okay, so in a histogram, right, the bars itself are always together. There is no space in between. Okay, whereas for a bar graph, there is a space in between. But regardless, most of the time, the question itself would have stated whether it's a histogram or a bar graph. Okay, but then back to this question, we are focused on trying to find out the standard deviation. In this particular histogram, if you look carefully at the end of the bars, it is actually within a range 200 to 220. There are histograms whereby at the end of the bar it's just a single number. It doesn't go in a range or interval. Okay, so in this case it goes in the interval. That means for this bar itself, there are actually 8 people whose weekly salary is between $200 to $220. Okay, and then in this case there are 23 people whose salary is between 220 to 240. So that means if I want to translate my histogram over here into a frequency diagram or frequency table, I'm trying to see it as though weekly savings 200 to 220, okay, and then your frequency is actually in this case 8. Alright, I do not know what is the inequality in this particular case. That's why I'm just using the word 2, because I do not know whether is it less than or equals to. Okay, but I must know and recognize what is the interval. Right? And then we will get 23. So this will be how your frequency table will look like, although you need not construct the frequency table. I'm just trying to be consistent with what we were doing earlier on. Whereby in order for us to find out the standard deviation, I must know what is the mean value of this interval. So again, lower and upper boundary add together, divide by 2. We will get 210 over here, 230, 250. 270 and 290. Okay, so I'm going to use this value and this value to input into our calculator so that we can get the standard deviation. Okay, could you give this a try and find out what is the standard deviation? Able to get the value in truncated 5SF to be 24.997. Okay, why am I bringing out the truncated 5SF? Because I want to show you and emphasize that in this question, again, we're talking about money, about salary. Okay, so with this value, you should be rounding off to the nearest 1 cent. Okay, so 2 decimal place in this case. In this particular case, the 7 causes the 9 to round up, so it will go into 25.00. You must write down the 0.00, okay, because then it is a rounding to the nearest cent. Okay. If you don't write the 00, then your accuracy-wise is not correct anymore. Okay. Right? Now, with now being 8:59 already, I actually have only one more question I want to finish up, which is exercise 3D question 17. Okay. But next week, okay, maybe to save you the trouble, no need to bring your EMATS textbook, just bring your EMATS notebook will do. Okay, after I finish that one last question, okay, then we will go into AMATS itself. Right? I will still assign you your E-maths homework, 3 questions. Okay, exercise 3D, question 10, 13, and 15. Alright? Okay, so those are the homework questions. Due on Monday, is it possible? Can? Due Monday? Please do give it a try to actually do your own statement writing. Okay? I want you to not rely so much on me, okay, in terms of your writing. Okay, that's all for today. Class is 10.